Okay, today we are going to be talking about one of the applications for exponential functions, which is population growth and decay. So, as we've been working with, the exponential or general exponential function is y equals a times b to the x, where a is our y-intercept or initial value, and b is our growth or decay factor. In percentage growth, if there is an increase, then b is 1 plus the rate. If there is a decrease, so this is growth, and the reason that is the decimal form of a percentage is 100% is 1, okay? And so if we had a 7% increase, we'd add 1 plus 0.7. And if it's a decay, we actually subtract the rate. Since 1995, the daily cost of patient care in community hospitals in the United States has increased about 4% per year. In 1995, such hospital costs were an average of $19.68 per day. We're going to write an equation to model the cost of hospital care since 1995. So first we're going to find our initial value. And since the first year, since we're asking since 1995, the first cost would be the 1995 cost. And so that is $968 per day. And since we're talking about an increase, to find b, we're going to write 1 plus 0.04. Putting that together, y equals 968 times 1.04 to the x power, where x is the years since 1995. So, to answer part B, we're going to use our equation. X represents the number of years since 1995. So, if I want to know y, the patient cost, I need to figure out how many years since 1995 is the year 2012. So we subtract 2012 and 1995 to find this. So our x value is going to be the difference between those two things, because that's how many years have passed. So we're going to be putting 17 in for x. So that's our setup, and we're going to use our calculator to find that value. Okay, and so I'm going to round to the nearest cent. That would be $18.85 and 57 cents would be the cost per day in 2012. Okay, now let's do an example where we have exponential decay or decrease. So, since 1990, the number of gallons of whole milk each person in the United States drinks each year has decreased by 4.1% each year. In 1980, each person drank an average of 16.5 gallons of whole milk per year. So, our initial value is the amount people drank in 1980, which would be 16.5 gallons. And let me talk a bit about why we subtract the rate from 1. What is going on is if we have a decrease in a number, we don't want to know the amount that's decreasing. We want to know the amount that are still drinking whole milk. So if it's decreasing by 4.1%, the number of people that are still drinking whole milk would be 95.9%. So I am going to make b 1 minus 0.041 which is 0.959. So, using our equation, y equals 16.5 times 0.959 to the x power. And this is where x is number of years since 1980. Just like above, we were modeling the cost since 1995. Once again, we're going to have to figure out how many years since 1980 has passed to calculate the consumption per person of whole milk in 2012. So 2012 is 32 years after 1980. So when I'm doing this problem, I need to make sure that I put in 32 for x, not 2012. So I write 16.5 times 0.959 to the 32nd power. Okay, so this is what I typed in my calculator. And if I wanted to stay with a tenth of a digit for gallons, this would be 4.3 gallons per year for my approximation. So there is our example or two examples, one for exponential growth with a percentage and one for exponential decay with a percentage. And then I'm going to write up here, just so we don't forget, that R is the rate, percentage rate as a decimal. We have to convert it to a decimal. So this should be enough information to do 1 through 7 on the 8-8 worksheet.